Section 11.2, Part 2, Exponents and Scientific Notation. In this video, we're going to focus on scientific notation. The first thing we need to do is determine what do we mean by saying we write numbers in scientific notation. Let's say that n is a decimal number. Then if we write that in scientific notation, we write that as a times 10 to the n, and a has to be some number between 1 and 10, but not equal to 10. And n has to be an integer. So we're rewriting this as some number that's multiplied by 10 to an integer power. So let's look at writing a few numbers in scientific notation. We have 8,720,000. So what we're going to do is we're going to rewrite this so that that part of the number is between 1 and 10. So the way I do that is I write it as 8.72 times 10 to the, and I look at how many places I would move the decimal place to get it between the 8 and the 7. So if I think of the number 8,720,000, the decimal place is there at the end. So to get it over between the 8 and the 7, we'd need to go 1, 2, 3, 4, 5, 6 places. So we would make this 8.72 times 10 to the 6th. Our next number, we want to focus on the 376 and write that as 3.76 times 10 to the, and again, we'll just count how many places we've got to move our decimal to get it between the 3 and the 7. So right now, it's currently here, so let's count 1, 2, 3, 4, 5, 6, 7 places, but since we move to the right, we make this to the -7. Now we're going to take some expressions and rewrite them in scientific notation and use our properties of exponents and simplify. So if we take this first problem, 0.085, let's write that in scientific notation as 8.5 times 10 to the 1, 2. So times 10 to the 2nd. Then we want to multiply that by 4.1 times 10 to the 1, 2, 3, 4. And actually, this first one has to be to the -2 because we moved our decimal place to the right. And then divided by 1.7 times 10 to the, and then we'll count that off, 1, 2, 3, 4. So that would be 10 to the -4. So now what we'll do is we're going to multiply our 8.5 and our 4.1. So we can use our calculator. And when we do that, we get 34.85 times 10 to the, and now we'll multiply our powers of 10. But remember that when we're multiplying powers of 10, or when we're multiplying with the same base, we add our exponents. So -2 plus 4 would be 2. Then we want to divide that by 1.7 times 10 to the -4. And now we'll take the 34.85 and divide it by 1.7. And we get 20.5 times 10 to the, and now when we divide, remember that we're going to subtract exponents. So 2 minus -4 would be 6. But our final answer is not in scientific notation. So we want to write that as 2.05 times 10 to the, and now we have to make sure we moved our decimal place one place. So we need to make sure that we write this correctly. So we want to make that to the 7th. And one way you can think of this is look at your number. You had 20.5 and you went to 2.05. So one way you can remember this is if your number went from a bigger number to a smaller number, so you went big to small, then what has to happen is your exponent has to get bigger. If the number gets smaller, the exponent had to get bigger. And if the number gets bigger, then your exponent has to get smaller. So let's look at the next example. So we'll make this 1.11 times 10 to the 1, 2, 3, 4 times 6.4 times 10 to the 1, 2, negative 2, divided by 8 times 10 to the 1, 2, 3, 4, 5, 6, and 3.7 times 10 to the 1, 2. Now we want to multiply our 1.11 and our 6.4, and we get 7.104. Then we're going to multiply our 10 to the 4th times our 10 to the negative 2. Add our exponents and get 10 squared. Over, and on the bottom we'll multiply 8 times 3.7. We get 29.6 times 10 to the, and now we'll add our exponents, and that'll be 10 to the 8th. So now we take 7.104 and divide by 29.6, and we get 0.24 times 10 to the, now I want to subtract exponents because we're dividing, so that would be 10 to the negative 6. But again, we're not in scientific notation yet, so we make that 2.4 times 10 to the, and since we took the number from 0.24 to 2.4, our number got bigger, so our exponent needs to get smaller. So we moved one decimal place, so we'll make that 10 to the negative 7, and that's your final answer. In our last example, we'll look at an application. If light travels approximately 3 times 10 to the 8th meters per second, we want to know how many meters per minute is that. So if we look at some unit conversions, we know that 60 seconds equals 1 minute. So looking at what we have here, 3 times 10 to the 8th meters per second, per means divided by, then I want to multiply by a conversion factor. Well, I'm trying to get rid of seconds and get to minutes. So we're going to put seconds here and minutes here so that the seconds will cancel. And we know that 60 seconds equals 1 minute. So now we'll multiply across the top. And if I take 3 times, we'll make this 6 times 10 to the 1. So 3 times 6 would be 18 times, and then multiply 10 to the 8th times 10 to the 1, I get 10 to the 9th over 1, and my units are meters per minute. The last thing I need to do, 18 divided by 1 would be 18 times 10 to the 9th, but in scientific notation, that's 1.8 times 10 to the, and again, our number went from big to small. So since our number got smaller, our exponent has to get bigger. So that'll be 10 to the 10th because we need to move one decimal place to get to 1.8. So we increase our exponent by 1.